Okay, seeing that we've surpassed the magic number of 50, let's get going. Let me move some things around here on my screen. All right. Well, welcome to a session on profiling data for repurposing, identifying issues of structure, quality, metadata, and provenance. Today, this will probably be just about an hour, maybe a little bit more. This is not a coding session. I know a number of you have found that Ravana is down today, and we're worried about that. We are on top of that, trying to figure out what's going on with the people in Charlottesville. They are on it, but no need to worry today. This is not a coding session. This is a conceptual overview, understanding of what is expected when you're going to be profiling the data sets that you've been selecting for your projects. Pseudo code is sometimes provided on the slides just for conceptual understanding, and it's up to you to apply in the language of your choice. Having said that, most will be in R, and you'll be learning how to manipulate data sets to achieve these ideas in coming training sessions very soon, but now you'll know the purpose. These slides will be made available both on Teams under the training and on the training repo. I apologize, they're not in there right now. I just finished putting them together. Doing things online has forced me to be very organized in comparison to just walking in live and popping up different things on the screen and talking about them. I suppose it's good for me in the end. Let's see, while it's not an interactive coding session, I've done my best to use flashy colors and sometimes things that move to keep your attention for the hour. Also, please don't hesitate to ask any questions along the way. Okay. I guess first and foremost, why did I highlight the word repurposing on the title there? I did that because you can profile data for any reason, right? You can be profiling data just going into the system the way that it's supposed to be going into the system and not being used for anything else than what that system is using it for. Here we are specifically talking about, in the data science world, repurposing data for specific reasons. For us, it's for trying to help decision makers answer policy questions. Right? Having said that, I'm going to start us off with understanding where that word repurposing belongs in all of these words that get thrown around in the data science data world. So let's say here you are, happy little researcher, and here's a data set that you would like to work with. Right? But it's locked away. Bummer. But if you get through that lock, there's all these other data sets. Let's say this is the state of Virginia that you can get to, but they each have different laws associated with getting to them too. Well, what if I'm trying to do that across a couple states, like say both Virginia and Iowa, and I wanted to link them up? Well, if I'm successful in doing that, then I want to try and answer a question with that, right? So there's a whole lot of steps in there that have to happen. So we're talking about the linking between the data sets, say within a state or within an agency or across agencies and states. That's when you hear people talking about the word linkage, privacy protected linkage, secure linkage, probabilistic linkage, right? That's the area that's the stage that they're in when they're talking about that. There's a lot of discussion these days about distortion, perturbation, creating synthetic data sets that help keep things even more privately protected. That's generally what happens after you've done the linkage, right? Before you deliver something to a researcher. But now that the researcher has those things and wants to answer a specific question, that's when we're talking about data repurposing, right? Determining the fitness of the data that we've been given and whatever state it is in for the question. And that is when we start doing data profiling to figure out, is this data fit or can it be made to be fit to answer that specific question? If you've heard the term IDS, you turn a little researcher into an IDS, that's integrated data system. That's what you call it when you pull all this stuff together. And you'll also see the term data governance thrown around, right? That means, how do we make all this work together? Okay, having laid the groundwork, It's time to get started. We'll start with what I call issues of structure. Remember, we're going to talk about issues of structure, issues of quality, and issues of metadata and provenance today. So when it comes to issues of structure, I'm going to talk about variables that are combined. I'm going to talk about multiple observation directions, combined observational unit types, divided observational unit type, and missing variables. What do all these crazy words mean? Oop. So combined variables, that refers to the condition when more than one variable is represented in a record field or column. Right? Sometimes we end up with column variable names being comprised of a combination of multiple underlying variable names or potential variables. It should be noted that many times this is an issue of problem definition, not necessarily bad design. Right? Common example with administrative records would be the parts of a birth date field. Right? For example, in the I've had many projects where you get a birth date field, but there's a requirement, say, to categorize students and education data by birth year. Right? To achieve that categorization, it's first necessary to divide out from the date of birth field the variables birth month, birthday, birth year. While this is often achieved within the programming of the query that you make, in fact, this is what's really happening. Okay. Data profiling issues of structure, multiple observation directions. This one's fun. This is a particularly messy structural issue, which occurs when a data set has variable names in both columns and rows. For example, a data set with a field column for each day of the month on the horizontal and a row title for month on the vertical. This situation occurs most often when the data provided comes in the form of cross-tabulated aggregated data. For example, here was some data that we worked with a couple of years ago having to deal with educational attainment. At that time, I also had a student who took a couple of these types and turned them into handy-dandy animations. So you can see what has to happen conceptually to the data when you get it in that form. Right? So for each variable, you basically have to create multiples of them and then associate each possible combination of those two variables with the value. And that's how you get your nice long, they call a long data set, right? Or what some people call a tidy data set. I'm hoping in the future to make these graphics even more whiz-bang with explosions and stuff to make data wrangling even more exciting. Okay, the next type, combined observation unit types. Sounds more complicated than it is. Within administrative records, multiple types of data are often combined for expediency. By multiple types, I mean different sets of data fields, each set representing a different type of observational unit, right? So in this case, I'm looking at some multiple listing service data. That's the real estate data. It has property information. Well, that's a unit of analysis. It has listing agent information. That's a unit of analysis. It has other things in there, right? The observational unit types necessary to the project at hand need to be separated out into individual observations or individual data sets in the restructuring phrase. So in this example from a housing case study, the multiple listing service data set that was provided to us was made up of single records with 128 fields, columns, right? So the graphic you're seeing there is not a table of data, that's actually a single row in a data set. So each original record was identified by a unique list number that you see in bold there. However, if a parcel was listed twice, it would have two different list numbers or more. As a result, changes in a property or parcel over time couldn't be tracked from these records because the structure is organized by the list number, not by the parcel number. So changing the structure to include parcel ID allowed the required historical tracking of the changes. So what we're looking for is more of an ideal structure like what you see on the right here, where I want to end up having 4 tables, where I want to have basically a linking table of property ID and location that's linked to 3 different unit of analysis tables: 1 property characteristics, 1 property sales information, 1 property tax information. And again, to conceptually understand that, we have a nice animation that shows how that would be created from this kind of data. Next, for structure, we have divided observation unit type. Within administrative data systems, it's also not uncommon at all to find that a single observation unit type has been split among multiple data sets. In fact, I would go so far as to say in certain types of agencies, especially local social service agencies, it's almost the norm. You can think of this as the conceptual opposite of combined observation units, right? Instead of having the thing that you're studying, having many of them in one row, now I have that one thing I'm studying, but split amongst multiple data sets, right? Which means there's a good chance you're going to run into differences in the way things have been recorded. Right? For example, there may be, as was the case in one state's educational records we were dealing with, North Carolina, there's separate tables that duplicate the collection of student demographics. What we see here is gender mismatches across 2 different data sets from the same education information system linked on unique ID of that student. So decisions on whether and how to transform inconsistent data as a result of divided observation, you need to factor in the magnitude of the issue, as well as the ability to accurately correct the data in a timely fashion. You have the, is it a serious problem, or is it a 0.0001% problem? And a primary decision factor in that is whether or not there's a systematic bias that's going on. But even then, is it systematic bias? Is it large enough that it's actually going to affect the statistics that are coming out on the end? And again, the last animation that shows this, we now have the 2 different tables. I link on unique ID. Oh, one's male, one's female. When I do them all, there's a bunch of differences. Okay. And this can happen a lot in, especially in education records. In education records, which usually get recorded 3 or 4 times per year. So there's a lot of choices that have to be made about, which demographic would you choose. Missing variables. Missing variables means the data set has values in column headers instead of variable names. It's not uncommon to receive tabular data sets that have been designed for the purpose of presentation, not analysis, where variables from both the rows and column headers and values, not variable names, right? Such files are often initially produced for the purposes of conveying aggregated summary data, usually to decision makers, not constructed to be a traditional data set that you can use. These are rarer and rarer, but every once in a while you still run into one. All right, so that was it for the structural issues that you'll be expected to look out for. On to quality. Data profiling issues of quality. This is where we talk about concepts like completeness, value validity, consistency, which I have actually split into 2 different kinds of consistency, uniqueness and duplication. I'm going to show you an example here real quick. Let's see. Okay, what you should be seeing now is something I did for the Virginia Longitudinal Data System a few years ago, where in their student record collection and in their student schedule collection, we look for these things: completeness, validity, right, etc. And we created a template for analyzing these. And you can think of this as kind of what we're expecting to come out of your analysis of your data sets, of the profiling. Here you can see this was a column on active status. We have the possible values here. And here you see a summary of the breakdown: completeness, validity, uniqueness, and a thing called a record consistency. Let's see. I believe if I look like an erase type, I also get longitudinal consistency issues going on. And using this kind of format, it not only summarizes what you've found, as you scan down, you're also sharing the code with them so that they can run it themselves. And as they try to correct things or simply validate what you found, they can run it over and over again themselves. Okay, let me jump back now. Does that work? Are the slides back up? Okay, great. My little box disappeared on me. Okay, so let's move through these. Data completeness. Data completeness, you could generalize it as the proportion of data provided versus the proportion of data required, right? Not necessarily all the data that's in there. Data that is missing, you could additionally categorize as columns not containing data, records not containing necessary columns, or data sets not containing requisite records, right? But the most common conceptualization of completeness is the first one, right? The column, the record field not containing the data. This conceptualization of data completeness can be thought of as the proportion of the data that has values to the proportion of data that should have values. That is, a set of data is complete with respect to a given purpose if the set contains all the relevant data for that purpose, right? Completeness is application specific. Right? You shouldn't just be saying it's all complete or it's all not complete. You shouldn't be looking at the whole thing usually. It'd be incorrect to simply measure the number of missing fields in a record without first considering which of the fields are actually necessary for completion of the task at hand. For example, in that multiple listing service, one with 120, that has 128 fields, right? Per record, many of these fields are missing data, tons of them, right? In fact, it brings up a whole nother discussion about why you'd ever design a system like that. When you design data systems, you have to know that only ever about 8 or 9 things at most, usually 5 or 6, are going to be filled out consistently, and they had 128. But anyways, for this one, many were missing data, but most of these fields were not important for the purpose of the study, right? Things like the listing agent's phone number and stuff like that. So it would not be helpful to categorize the proportion of missing values for these fields. Instead, a decision has to be made as to which ones belong for the current purpose, right? An example pseudocode would look something like what is up here, down below, right? Where I'm saying, for each field in a list of fields that I needed 1, needed 2, needed 3. Let's count the needed field, 1, 2, or 3, where it doesn't equal 0, where it's not blank, and it's not null. Okay? Now, this is important. In almost all, yeah, I'm gonna say all languages, but it's in almost all languages, right? You can't simply look for one concept of missingness. You need to look for all of them. right? This is especially true in R. Most languages, some packages will have a specific function written for that. I know, I believe dplyr has one, but you need to check for them all. That's why in R, I have this function over here to the right that I wrote. Its variable is blank, and you can see it's testing for null, it's testing for length, it's testing for is NA, and it's testing for a string that's simply missing. All right. Okay, moving on. Value validity. So the concept of value validity can be conceptualized as a percentage of elements whose attributes possess expected values. The actualization of this concept generally comes in the form of, if you're into militaristic jargon, domain constraint rules, right? For example, to ascertain how many entries contain non-valid values for a non-empty text column representing gender, an example, pseudocode domain comparison constraint would look something like what is up here, right? Count gender where gender is not in a list, male, female, no answer. It should be noted though that in many discussions of data quality, this concept is simply referred to as validity. If you look it up in Wikipedia and stuff, right? However, if you are in the behavioral and social sciences, you know the term validity has many, many different and complex meanings and intended sub-definitions. So it's not useful to just throw that term around. Therefore, I always use what I call the sub-definition, value validity, to be specific about what type of validity we're talking about. So here's an example. While profiling multiple listing service data for a particular locality, we discovered that the values entered in the field for zoning varied extensively. Right? It was clear that the mechanism of input was free text. Right? The domain comparison constraint, or the value list, was the zoning district. We can see it there below, which says comparison constraint, right? Everything there in that comparison constraint is what's supposed to be in that zoning column, right? But it was a free text field. So it was actually found that none of the entries for this field in this particular data set qualified as valid values. Right? However, remember what I said about doing these things for a particular purpose. Right? There may still very well be usable information contained within that field. The lack of valid value simply points to a potential problem in need of further investigation. For example, if the question at hand simply required a count of how many properties were residential versus any of the other types, it may very well be possible to transform the existing entries to adequately represent that to a true or false in this respect. In fact, in this data set, I did look at it, and sure enough, everything that should have been in R1 through R8, whatever they put in there, it started with an R. So you probably actually could have transformed that fairly easily into a true false. Is this a residential record or not? When possible, it's very helpful. And by that, I mean, do it if you can. To determine when and where errors have been made. Okay? Many times errors are specific to a place and time and therefore can be controlled for. Right? This is one we did with the Virginia Department of Education. I don't remember which column it was, but you can see that I have invalid entries by school year. A lot happened in 1 year, 2007. And then out of the, I forget how many we have, 200 and something school districts that we have, 100 and something school districts that we have in Virginia, one in particular stood out as where almost all of those mistakes were made, right? So you can control for both of those factors in your data. Also, sharing these results with the data provider helps them locate and correct these errors themselves. They can go back and they can fix these, right? And I have found there's no better way to sustain a lasting relationship with the data provider than to be able to feed these back to them so that they can go and figure out what's going on. Excuse me. In fact, there was one time we found a sizable number of birth dates on the day were incorrect. And in doing the same thing in time and location, we found it came down to one person who apparently was dyslexic doing data entry in one school system. And that was correctable. Okay, on to the consistencies. You'll notice there's a difference between a record consistency and longitudinal consistency. So by record consistency, you understand this as the degree of logical agreement between, let's say, between columns in a single data set, right? Although you can also think about it between two or more data sets as well. But usually you're talking about your data set. There should be a logical agreement between two or more columns in a data set. When there's an expected logical relationship between two or more entities, we can refer to the rule specifying this logic as a type of relationship validation called a dependency constraint. Right? Therefore, consistency becomes the degree to which these attributes satisfy that dependency constraint. An example of a logical requirement, might be, well, here, what do I have on there? Yes, a simple example would be something like a location disagreement between zip code and state code, right? If you have both of those in there, that's something that you should be writing code to check for, that there's agreement there. Another one, say you have a health record and you should be checking, if there's one that says you're pregnant, you should be checking whether or not it's male or female and see if there's an inconsistency there. Right? More complex example would involve consistency validation of fields associated with, it's when we had to do a student withdrawal in education records. That was actually in that system that I showed you. For example, most education records contain some form of active code categorizing the student's current form of interaction with the educational system. Most systems will also have a code for inactive or not enrolled. Most systems will also have a field for withdrawal date. So if a student has been categorized as inactive or not enrolled, but does not have a withdrawal date, then what happened to them, right? That's a consistency issue, and that was actually one of the things we were looking for. In fact, that's exactly what these graphs are representing, right? Where your active status is inactive, but there's no record that you exited, and there's no date. There's no code for exiting, and there's no date, right? So there are definitely some problems in this data set, but you will notice that the problems all went away after 2007, right? So right there, I know I have 7 years of data that does not have this mistake, which is terrific. And again, we broke it down by school division as well to figure out where the issues were coming from. Okay, on to the other form of consistency, longitudinal consistency. This is when there is an inconsistency in the data checked over time, longitudinally, right? You're trying to see if the same value is recorded for every new record when you know it should be. Things like a birth date and some other demographics. Remember, I talked about in educational records, they get entered 3 or 4 times a year, right? That birth date shouldn't change. That's what you're checking for longitudinal consistency. Right? Here's some pseudocode. Give me the count of students records if I join it to itself on student ID where gender does not match. If you don't understand what join to itself means, don't worry about it when we get to databases and SQL. It will become very clear. But the basic concept to get across is we're looking at demographics over time. So causes of inconsistency are varied. But a common source of inconsistency comes from situations where locally derived information is provided with no associated master list or file, like a master list of people, right? An exhaustive master list of individuals receiving public service are, in fact, quite rare. Okay? I've seen this in, well, I think I've already talked about it in education departments. Yeah, where we've had, where you saw the North Carolina education data, where we had student demographics being recorded in multiple systems, and when you put them together, a lot of times the gender didn't match, right? In fact, in the Department of Education, Virginia Department of Education, we found about 16,000 where that was the case. But it's out of 2 million something, right? So actually it's fairly small. Social service records at the local level have to be the best example of this. And it's certainly not their fault, right? Your social service agencies at the local level are the delivery point of services that are being financed by and administered by the federal government, the state government, and their local government, right? Each one of those systems, each one of those benefit systems has its own information system attached to it. And linking between those across levels of government is not only hard, sometimes it's especially forbidden. Right? This is specifically something that I've worked with the Arlington Department of Social Services on coming up with a way to do a probabilistic link between all of their different systems so that they could actually answer a simple question like how many people got served today. Right? It's actually an incredibly difficult question to ask. Race, a consistently troublesome demographic variable. From a longitudinal consistency viewpoint is race. Right? I mean, one, sometimes people periodically elect to change the racial category or not answer it at all, right? But more often what happens is the race categorization scheme that was being used gets changed. In fact, it can happen fairly frequently over, over decades, right? Here's the one and only question of the day. Why do you think that is? Why do race categorization schemes change?
Could you, like, is this considering like changing from individual races to adding another category where it says like mixed race or multiple race or things like that?
That would certainly be, yeah, that would certainly be one way, right? Where you go from 5 classifications of race, then all of a sudden you go to 9. Or these days, the newest one out of census is 99 different versions. Jesse, pretty good answer, because they are cultural creations and so they change. They are cultural creations, yes, but I'm asking why do they change? Let me ask this, why do we ask race in the first place? Increase inclusion, good guess. Do you think we asked for the same types of racial categories in every country around the world? No, right. And the basic reason is that you collect race and some other demographics, but definitely race, because something bad happened in the past. And the government needs to figure out where those people who had something bad happen are, right? Now, governments can wrong a lot of people over time, right? In their nature. So when they first get active and say, well, who have we done the worst to? And now we're trying to correct that situation. Well, we need to figure out where they are so we can distribute money via the governmental system in certain ways to certain programs, right? So you break race up into 2 or 3 categories. Okay, well, great. 20 years later, you say, yeah, but you also wronged these people over here. Ah, you're right, we did. We're going to need to add a few more categories. So you add a few more categories. And pretty soon you get in a situation where people are saying, well, wait a second, I kind of qualify in 2 of these categories or 3 of these categories, right? And that's when you start getting a system like what the census is coming out with now, which basically gives you about 99 different combinations of racial categories. So why does that matter to us? Because when we are looking at administrative records over long periods of time, many times what was being asked in terms of race has changed. Right? Like I know in Virginia over the last 20 years, I believe there was a 5 versions of race that went to 9, right? And you need to know when that happened and where. And can you, if you need to get them all to a common set of racial classifications, can you? Right? So very big simplification. If I was just asking Caucasian and African American for years, but then all of a sudden I add in Pacific Islanders, Native Americans, a whole bunch of different ones, and both the white and black go down. How do I roll those back up in so that I can have one common data set, right? Sometimes you can't. So understanding where all those changes have taken place over time in your data, race is a great example of, they do change. They change for sensical reasons, as far as government policy is concerned, but they can make using that as a variable very difficult over time. Let's see, what did I have here? Yes, here was a SQL query that I wrote to check that in the Virginia student record collection on race. And here we saw about 160,000 had a switch in that time period from 2005 2015, which makes up about 7% of all the data in there. Okay, duplication. First, the degree of replication, of distinct observations. For example, in a state level secondary education registration records, greater than 1 registration student, as I've been saying, is made per year. However, what's important about duplication is to figure out if the duplication is on purpose or if there were accidental records duplicated, right? Because that's not the same thing. For instance, in education records, you would need to look for, let's say, a kid's data gets put in 4 times per year, fall, winter, spring, summer, right? You'd have to actually look for duplicates of, say, fall 1992, right? Not just fall, not just that kid, to actually ferret out what the duplications are. And then uniqueness. So uniqueness really isn't usually talked about in terms of data quality because conceptually it's not talking about, is it bad or good uniqueness. The reason I always include it is that it is the fact that if you have a very homogeneous data column, right? If everything's the same, right? If I'm doing all of my analysis inside the state of Virginia and I have a state category that's all Virginia, right? I can't do anything with that statistically. That doesn't help me at all in ferreting out things. Oh, I'm sorry, I missed a question. What about creating subcategories like decision trees to keep the old data with the new one? Still think about the race issue. Yes, that's exactly what you try to do, right? You try and make decision, that's what I was talking about when I was talking about rolling it up, right? You try to make decision trees to roll them up. The problem is sometimes you don't know where the branches broke, right? And that was my example of Caucasian, African American. You had a bunch of other categories, but both Caucasian and African American go down, which means both of them have gone into those other categories. right? So at that point, it's impossible to draw that tree. At that point, you're trying to figure out, is there data that, how much data can I throw out that and still get a meaningful result? I hope that answers it. Yeah, thanks. All right, motoring through. This is where I ran out of slides. So in 2 slides, I'm not going to do all of issues of metadata and provenance to finish up. So, I mean, we know metadata is often, called data, provides information about other data. Yeah. Find it much more helpful if we can break it down into what's wrong with our metadata, right? Because a lack of metadata for a data set can present significant impediments to the use of that data set, right? Being very specific, when we're dealing with data that's being used for research purposes, it's vitally important that we discover if the data sets, their observational units, the records, the rows, and their attributes, the fields, columns, are consistently named, sufficiently described, and appropriately formatted for analysis and combination with the other project data sets, right? Additionally, does any information exist on any transformations that have occurred to the original data sets? Highlighting specifically the first one, observation unit definition, right? When a data set is provided without definition of the purpose of that data set, we have an issue with that, all right? Why was this data collected? When dealing with data sets not originally collected for research purposes, there's often no easy answer to that question, right? To correct this issue, it's often necessary to first generate separate new data sets from the data set provided, each representing only a single observational unit type, like I was showing in the multiple listing service, how we had to break that out and create new observational unit types. And that means at that point you are in the position of creating the metadata. So other than administrative records, you run into these types of issues a lot when you're dealing with third-party produced data sets. We've worked quite a bit with some third-party housing data sets in the past, right? Proprietary ones. In fact, I'll go to the next slide here. Oh, it's the crime one, sorry. I'll go back to that. Yeah, the biggest issue is that when you find things that are missing or don't agree with other, say, open data sources that you have, say are right, you quite often don't get to know why. Right? And that really doesn't help you. That's where you start talking about provenance. Okay? So where has this data been? Who owned it? And what did they do to it along that chain of ownership? Like provenance of design data collections, like doing surveys, right? That's generally almost always available by definition. The purpose and the methods of collection are usually documented as part of the study design, as well as any transformations that had to be applied during the creation of the analysis data set from the collection instrument, right? For administrative data, however, provenance is generally not readily available. That's why personal contact with the data management personnel is critical to get a necessary understanding of the methods of collection that were used and any transformations that may have occurred. Those of you who are on the Charlottesville EMS project, we're seeing that right now, where you're starting to get your data sets and you don't know what they mean. You got to go to the person who actually touches the data to understand, because the policymakers just above them generally don't know at that level, right? Although it's just as necessary to have personal contact with the policy level personnel, right? Because to discern the original purpose of the collection. Okay, an example we ran into of that was a property crime example. This was data we got from a commercial data provider, which provided indicators of neighborhood quality based on quote unquote patented algorithms. We were unable to reconcile differences found in their crime indexes and data from our own Arlington County, from the Arlington County Police Incident Tracking System that they graciously let us have data from. Right? The figure presents the misalignment in these data sources by census tract. This figure shows property crime counts. It's calculated by the commercial provider and as directly pulled from the Arlington County Police Incident Tracking System. Right. The county data had 5 census tracts with counts greater than 300. These were not shown in the box plot to allow for better scaled composition to the commercial provider. The commercial provider did not describe nor make available, and we asked, right, what methods were they using to adjust these counts? And at that point, you know, as a researcher, all of that data has to be considered, you know, probably untenable. Right? So don't go off thinking that all most of your commercial providers, some of the data is very useful, but what they've really done is the legwork in going out and simply aggregating public data that's already out there. Now, sometimes if they run into issues, they will run their own custom algorithms to make it all make sense to them. But at that point, it's proprietary, right? So it's definitely some of the questions you want to ask before you buy any of those data sets. Okay, folks, that is all I have on structure, quality, and metadata and provenance. So I'll make these slides available. And this is the, now as you get into your projects and you're being asked to profile the data, hopefully this will give you a structure to go by, right? And to talk about things. We should all have a similar vernacular now as we go forward and talk about the data issues that we are running into. Okay, any questions at this point? Thank you. Okay, well, I am always available via email, and I will see you all later. Thanks, and have a great day.